Yeah.
So what's
You
the
got,
difference?
so all you're doing, that length there is that one, and that one there is that one.
That's why I'm on, okay.
Okay, so we'll start out today by
The
looking
opposite.
at
Right.
what kind of questions you have with the homework. Are we so far along, everybody's good with them?
So,
Not so much? That's fine. What should we look at first?
so on E,
Okay, what page are you on here?
11,
Now your normal.
clarification on this one.
It's chilly in here today for a change. So we're looking at E,
Oh, seriously.
okay?
So, it gives us a force of 60 pounds to the left.
Yep.
Is that 60 pounds from where the 80 pounds intersect? Or that doesn't matter because you can move the force anywhere? So I'm looking for the, you know, when you're gonna do the R value there,
There's 80
Yep.
here and a 60.
I'm guessing it's gonna shoot off to the left.
I think, how we
I'm just wondering, since that 80 pounds looks like it's halfway in,
Yep.
do you close that off right there where it ends, or do you gotta move that line over?
Does the location of this matter to us in our
I
analysis?
remember you said no on that, so,
We can't move it in this direction, right?
no,
Well, I'm sorry,
not the
we
lateral,
can't use the 60, we can't move the 60-pound force
up or down.
up and down in the direction of the board. But we can move it as much as we want, as long as we don't change that line of action of it, right?
Right.
So if we wanted to,
So we
we
move
could
that
say-
over,
yep. You can move your force to there,
okay.
okay? And yeah, that's what I would recommend whenever you see
An
Whenever you see a
intersection.
setup like this, yep, set up your intersection because now it's gonna make it easier to set up your force polygon.
But you, since the 80 pounds is going down, your R value would be southwest,
Correct.
if you're looking at it as an
Yep,
axis.
yep, because then you're gonna get into a case where you're just gonna take your 60 pounds up here, you're gonna take your 80 pounds here, right? And then draw your result.
Or you do it out of like the third quadrant, like if the 80 pounds is going down,
What happens if you take the 80 pounds and start at the
at the,
horizontal line and goes down?
that's what I was,
Transfer your
just because of
line.
the direction of the force, so if you take the
They're
80 and
moving
put it
the
under the
80 as
60.
well. They're moving the 80
Oh.
down below.
Oh,
So you got your 60 now as your top line, that line.
yeah, how you
So
So
manipulate,
that
how
line
you
is still
manipulate this is
southwestern,
irrelevant.
just go into the third quadrant, not the fourth,
Yep,
if we're looking at it as. Yeah,
yep,
what
do
I
you
mean?
wanna come and draw it?
Yeah.
Just because I think that,
He's just
I'm seeing
moving
it in
the
my
80
mind's
pounds
eye.
down the line of
I'm still
action
like
Yep.
in.
to under the
Nope,
60.
it's fine, it's fine,
So the 60
yep,
Yeah.
would remain.
But yeah.
yep,
Oh my gosh,
but we're just trying to find where.
so 60 would be here.
yep,
And this used to be here, but instead we're gonna start it here.
sure,
And that'll be our 80.
Yeah.
And our R value.
yep, yep, because now you're just gonna have your dotted lines here.
Right,
Yep.
but just because when I look at the arrows, it makes me not want to work up here, it makes me,
Yeah, that's fine.
you know, like, I don't, what class were we doing? It was surveying.
Surveying, yeah.
Yeah, we,
You do it either way.
with surveying, we just always moved it
They are.
to where the direction.
$10.
Sure, and that's fine, and so the question that Rush brings up is a good one, yeah, you're absolutely right here, is,
So that's the same way as moving the 60 over like.
yep,
Yeah.
Yep.
You're going down the same line of action. You can move it wherever you want, up and down for the 80 pounds,
yep,
side to side.
and regardless of then where we select our reference, whether we select our reference along the axis of the 60 pounds, whether we select it 4 feet away, you know, assuming that that's 4 feet away, right?
Yeah,
Won't this angle and, let's see, then if we move this guy down,
it'd be the same.
those angles will still be the same, correct?
Yeah,
So we're not altering the line of action of our resultant. We're not altering the sense of our resultant. and those steps aren't going to alter the magnitude of our resultant, okay? So, either of those is fine. You're fine to move your forces however you want along that same line of action, okay?
Okay.
So what's the answer? 100 pounds at some angle.
Let's see, 6,400 and 3,600.
Where,
Yeah, so 10,000, so yeah, you're gonna end up at 100 pounds?
And then you just have to figure out the.
well, at A through F, I think we're only doing the R value, we're not looking for the angle. We're just worried how long the line is, wasn't that the, I think I read that wrong.
Well, I thought I asked you for the angle.
Replace the single force by components.
Somewhere between 0 and 90, yeah.
It asks you to determine the resultants. So resultants, the definition of the resultant is the magnitude
Yeah.
and an angle.
And
So you
an
will
angle.
need an angle. But if you think back to trig, if you've taken it recently and haven't purged it all from your memory banks, 60, 80, 100 is what type of a triangle?
What is that, 4, 5, 6, or?
3, 4,
It's a 3, 4, 5 triangle, right? And so keep in mind what you know about 3, 4, 5
So it'd be
triangles.
Right
100.
triangles.
They're right triangles, but what do you know about the angles in a 3, 4, 5 triangle?
40, it's
You go
equilateral.
180.
30, 60, 90.
45,
30, 60, 90.
45, 90.
30, 60, 90. With two 45-degree angles, then you get into, we would have same magnitudes
Oh, yeah.
along here,
The
right?
equilateral triangle.
Yep.
So it would be 100
Mhm.
and
Yeah, so you're-
30,
30 degrees.
it'd be a 30-degree angle. But which way are we taking the angle from? Inside the,
That's up to you to determine.
either one would be right, or?
Yeah.
So it could be at a
If
60
you're gonna
degree
say it's here, then you need to determine that angle.
Well, I'm saying, are we taking the angle from inside the closed triangle, not from the dotted area? Because if it's 30 degrees up there, then it'd be 70 on the outside. But we keep it inside, correct? Keep it inside the triangle we just made.
You can define your reference line of action
Okay,
on your resultant, okay?
Okay.
As long as it's defined. I'm not interested in trying to define that for you, okay? What have you found to be most successful? Are you solving with trigonometry, or are you using a ruler and a protractor?
You don't have a protractor.
What?
First sounds terrible. First one, use trig. So how would you solve each trig for like, one that's not in the cube? Not 90 degrees.
One that's not 90 degrees?
So like
Let's
D,
look at,
right?
which one did you want to look at, Terry?
yeah.
Yep.
Yeah.
Yep. Do we need this up anymore? Or is everybody good with this?
What the hell is
Are we good if I remove what's up on the board, or do you want me to leave it up here for a little bit longer?
Yeah, I'm good
Good.
on that. What'd you get for A then? The angle, I mean.
Sorry, remind me of my forces. What's the force on this guy?
You got
60 pounds.
60 going down, and to the right is 100. The
It's a
angle.
120 degree angle.
60 pounds, 100 or 120, sorry?
100 pounds and then
100
the
pounds?
angle is 120 degrees.
120. Okay? So, any idea on what we want to do first?
Do the same thing. Take the 60 pounds.
I would move to 60. That's just me though. My
You want to
brain,
move to 60,
Yes.
all the way down? Okay.
my
I'm
brain
fine with
just
that.
can't process it.
Okay, so we'll redraw. So we have our 100 pounds running along our axis, okay?
60 degrees now.
There's 60 pounds.
So So it'd be a 60.
Terry says we have
angle.
60 degrees here. Does everyone agree with that?
Is that what that is, right?
Yeah, cause I'd make 180.
Why did,
Make
Yeah.
a straight line.
exactly. Yep. In order to have a straight line, we have to have 180 degrees between those two angles, right? So if we're translating our force down into this quadrant without changing that angle, we have to have 60 degrees in between them. If we have anything other than 60 degrees, we've changed our line of action, okay? We're no longer analyzing the same force. Does that make sense to everybody? All on the same page? Okay? What should we do next? Do we want to solve it with trig, or do we want to make a force polygon? Want to solve it with trig? Okay? So what would you want to do?
Like what's the
Well, you would,
Or what do you ask? That's what I wanna know. What do you ask?
What would be our next step to determine our result?
I mean, plug the numbers into the formula.
Okay?
Square root of a squared plus b squared times 2a cosine theta.
but
Oh, you want to solve it using the law of cosines?
I mean, how else would you do it? Because you couldn't do.
Do we know enough information to
Because it's
use law of
not- it's not
cosines at this
finished.
point?
No, so we don't know a second angle.
Two sides
we don't-
and an angle.
But we don't have a closed.
you gotta close it.
We don't have a closed
So
triangle.
you gotta
now.
run from the 100 pounds.
So
But-
we need another angle.
Okay, but what if we put 100 pounds
100
here?
there, and then 60 down, and
Okay.
then chop that with your R.
Okay.
Triangles.
I think this is one you don't want to put.
And then the top one
What's that?
becomes
This is one you
30
wouldn't wanna
degrees, and the bottom one's still 120. So you have 30, 120, and then you know that you need another 30 degrees.
Well, I think that you'd end up
Which one?
kind of
would you
with this, regardless of how you look at it.
120
I think you end up with the same-
60
Yeah,
is
same
thing.
right there, just because it's, you know what I'm saying? And then that top one, since you split 60 and have to be 30, so you need, the bottom one would also be a 30 degree angle, it'd be 30, 30.
What do we know about this angle?
So
Larger than
100.
120 degrees.
It's larger than 90 degrees. Why do we know that it's 120
It's the
degrees?
exact same angle as our original problem.
Okay, so now, Justin, now we can apply the law of cosines, okay? So, what do we want to figure out? We want to figure out this guy, right?
Right.
So C equals, we'll call that C, well, let's call it R. Consistent with the language used in the book, right? So what does the law of cosines tell us? What does R equal? Square root of,
A squared plus b squared, plus 2ab cosine c or whatever.
2AB
Cosine of the angle.
cosine of that R angle, right? Give me a second, I want to verify that. I don't have the law of cosines written down in front of me,
I think
so.
it's a squared plus b squared minus 2ab cosine of that angle
Minus 2AB, yep.
with no square root.
No, it's just square root.
Well, we need the square root, right, because these values are squared, so we have to square to get that value,
We can get one for, sorry, 116, 162.
okay?
For your angle,
Oh,
or this side.
And now we have everything we need to know, right? Okay?
so
It's a little bit more of a
can
grind.
be what either side you want to choose, right? A can be the 60 and B can be the 100. Is that what?
In this case, A and B can be whatever you would like them to be.
You just have to be very consistent.
You just have to be consistent in your calculations.
Yeah.
So if you're using like trig to find the angle later on, you have to make sure you use the same versus there.
Yeah,
We don't need to.
But we need
careful, because we do need,
R, don't we?
yeah,
Yeah, I think
That'll find.
I think you use like cosine of r. I don't think you should use r. 'Cause I think that's where you
Because if we're figuring for R, how do we have R in the
Oh,
equation?
I see what you're saying,
Just
sorry.
cosine of theta.
Okay,
Yeah.
okay.
Does that help
Yeah,
clarify?
yeah,
Thanks, Justin.
yeah.
Yeah, I didn't think of that.
Oh, I don't have my.
Okay, is everybody comfortable plugging and chugging this number? We don't have to step through it? What about, is everybody comfortable with getting to a number to tell you what your reference angle is? Can you figure out these two angles?
Yeah.
Taking a damn picture.
So if we have law of cosines here, we could also use law of sines. Does everybody remember law of sines?
It is,
I don't think it all, I don't think it
It'd be
all
30.
will.
That angle right there on the top left?
It has to be split in half.
yeah,
They're all parallel.
yeah.
No,
Yeah.
because the alternate and inferior ones have to be the same. That doesn't mean those top two have to be the same. I don't think, I could be wrong.
So would that be
What do you say?
120
With
still
those
then?
angles, the 60-degree angle, since we cut it in half with your R there, would that be 30 and 30? Does that equal out, or is the angle?
I would be careful,
different?
because remember you have different magnitudes.
Okay, so it won't be
So it'll
cut it down
remain
the middle then.
The angle at the top is the same as the angle at the bottom inside.
Right,
Yep,
yeah,
those will be the same, and those will
right,
be the same.
okay,
These aren't necessarily equal,
okay.
okay?
So we, okay.
But why can't do that? The right triangle.
I got it.
Sorry. Yeah, you can.
Only with the right triangle can you do the diagram here.
Does everyone feel comfortable with solving this from here?
Yeah.
Do we have to, or do we have to look at anything else?
Can we get just an answer for this one to see if, like, I calculated this right? If I did.
Sure.
What'd you get?
So you've got square root of 100, so you have 10,000,
That's the other.
plus you have the square root of 60, so you have 3,600. So that's 6,000, and you're minusing it by the quantity of 12,000 and cosine of 120. What's cosine of 120? Has anybody calculated that yet?
Negative 2.5.
Yeah. 600 minus, does that become 6,000? So square root of 7,600? So that's
87,
roughly,
87.17797887.
cut? Okay?
Why,
Is that you got?
87, yeah.
so,
Not ready for school today.
First day back, from like the 3 days.
How about resolving what our angle is?
Say again?
Resolving this angle.
so,
Is everybody, I mean, is everybody understanding what I'm saying when we're talking about the result and resolving the angle? So you'll need to at some point figure out what your reference is. Whether your reference is to this point, whether it's to this, you know, with respect to this axis, doesn't matter to me, but we need to have some way that we can communicate what direction this force ends up being in, okay? So you just need to be able to include that it's 87.2, I think we're just in pounds, right? 87.2 pounds, whether it's, 15.2 degrees down from that angle or oriented 85 degrees from, 165 degrees from that angle. Okay, so make sure that your answers all include both a magnitude and an angle from some reference. Okay? Other questions on the homework? Or is this as far as you've made it? Is into the first set of problems?
I was honestly skipping around a little bit.
Okay. So is the best use of the next hour of our time to continue working on the homework in here? And we can address problems,
It'd be nice. that
issues
we
as they come up?
pass. This is.
That's
It's been
fine.
It's been a couple of semesters since I know at least half of us took trig.
That's
Might be
fine.
a bit longer for you guys.
I'm fine with using that time to do that today. Okay?
So, we use our rulers and we're scaling this, right?
You can.
Typically,
You
you
can.
can have a protractor and read that angle.
Yeah, absolutely.
You know what I mean?
Yep.
Instead of doing all the,
Yep. Yeah, I want to make clear to everyone, for the purposes of this exercise, you do not need to use trigonometry to solve these problems. Okay? You may use a ruler and a protractor and draw things to scale. But you have to make sure then that your 100 pounds is 40% longer than your 60 pound.
well, you
Right.
could- yeah, so on your ruler, let's say 100 and 60.
Sorry.
So you're going in 10, so.
Sorry, 70% longer. It'd need to be 2/3 longer, right?
Yeah,
This would have to be 40% shorter than your 100 pound.
so let's just take it by 10, so you got 10 and 6.
Yep,
You just 10 tick marks on your ruler.
correct. Yep,
Yeah, it's called units.
10 units, whatever they are. Yeah, I mean, I have an engineer scale up on my desk. It's got 6 different scales on it.
Right.
So depending on what size magnitudes you're using, you have different scales that are available to you to draw to you, and they're different unit sizes on there. If you're more comfortable drawing that way, absolutely.
Word doc?
I'm sorry?
It's drawn out and then uploaded.
Draw out and then just scan it in and upload it.
One hundred.
No, well, I was gonna use it.
Well, if you use 87.2, you'll get 120.
Okay, so let's plan on that. Let's plan on, we have 1 hour left. We won't move further along. I do want to take just the last 5 minutes to introduce just the concept of axial forces. We're not going to go into great detail on it. I just want to make sure that you have a clear definition of axial forces, because I don't think that the book does a very good job of that, so that when you're looking at the reading for the next chapter, you understand what it is that they're getting after. So I'll turn off the camera for the time being. You guys can work on some problems. As things come up, we'll take a look at them.